Welcome to this latest edition of our hugely popular Cummings Pepperdine Crypto Questions. This one's slightly different as I'm not going to be talking. Instead, Michael Borrelli, who's our head of regulatory solutions, is talking to Mike Anderson of the Convex Foundation about how he is working to improve the layer one blockchain. A word of warning. Mike is actually in Singapore, so you'll hear in the background his fan going to keep him cool. I like to think it's a touch of the exotic and it shows the wide scope of reach of blockchain, crypto, DeFi, and what we try to bring you here on our hugely popular Cummings Pepperdine Crypto Questions. So carry on listening and enjoy.
Good morning all. Welcome. It's Tuesday, the 17th of May 2022. My name is Michael Borrelli and I'm here as Cummings Pepperdine. I'm here with Michael Anderson, the founder and CEO of the Convex protocol. Welcome, Mike.
Thank you very much, Michael.
So it's a pleasure to meet with you today, and I know the time difference is, so you being in Singapore, so I won't keep you too long. I know that you're very busy developing Convex, and we'll get onto that in a bit, but with these hugely popular Cummings questions, I have two questions I wanted to ask, if that's okay.
Sure, that's absolutely fine.
Okay, so first question, what got you into crypto?
Well, that's a great question. I was originally working with a number of companies on data science and artificial intelligence. And I got the opportunity to take up a job, a CTO role, with Ocean Protocol, which was a decentralized system for data exchange and AI and machine learning services. And the idea here was you wanted to enable these powerful flows of data on a decentralized basis between different market participants. And the idea was very much to use crypto technology to achieve that. So I got a great introduction into the world of crypto by doing that role. But I think during the process, I became a bit dissatisfied with the level of maturity and capability of the existing crypto protocols. In particular, they were very slow, very expensive in terms of transaction fees, and also environmentally damaging in the sense of the amount of energy that was being consumed on proof of work. So that got me into thinking, okay, well, how can you build a better type of crypto network? And that was where the original ideas for Convex came from.
Amazing. And when did you think of Convex? What was your watershed moment?
I guess the key insight for me was thinking, well, what does it need for a consensus to become stable, so that all the participants in the network can be 100% sure that which transactions have been executed and in which order. And I was aware of some techniques in the computer science literature about convergent data types, which are special data types which enable information to converge to a single consensus value. So a lot of the initial ideas behind Convex were about thinking and brainstorming and, contemplating in the shower about, well, how could you make this technology work in a decentralized crypto network? And in the process of that, I came up with this concept of convergent proof of stake, which is a new type of consensus algorithm, which enables very, very fast consensus to be agreed between a large number of different peers in a network who are sort of validating all the transactions. And this actually enables then the possibility to make a much, much faster type of decentralized network, which is what Convex has become.
Incredible. What are the three main issues or problems that Convex solves that nobody else does?
That's a great question. I think the first one I'd say is that a lot of these previous networks have struggled with is scalability, which is like the ability to push large number of transactions per second through the network. And that's because of the limitations of the consensus protocols and the limitations of the execution engines which run the smart contracts. So we've managed to solve that in the sense that, we've got the virtual machine which can handle up to about 1 million transactions per second.
Good Lord.
Which is, way beyond what anyone currently needs, and certainly way beyond anything like the Visa network or traditional financial systems. And I think more importantly, when you look at complex transactions like exchange trades, we can do around 50,000 of those per second, which is again far faster than any existing crypto network. So that's a scalability challenge. Can you just get enough transactions through so that the ecosystem can run all of the different smart contracts and digital assets that it wants to handle? The second key problem I think we're solving is that of low latency. So particularly when you think about retail applications, consumer applications, games or metaverse, virtual reality, one of the most important things is how quickly can you execute and confirm a transaction. So traditional blockchain networks have been taking, minutes up to half an hour to confirm transactions properly. And there's been a lot of progress being made on that, but because of the convergent proof of stake is so fast, we think we can get that down to about a second. So we are basically the lowest latency decentralized network, which is, I think, going to be critical as we start looking at the next generation of decentralized applications that really want responsiveness for the users, whether that's mobile or gaming, etc. I think I'd say the third thing that is, as a software guy, I think is a really important innovation, at least, is the programming model, which is how you express the code and execute code in this decentralized environment. So we've built an entirely new virtual machine, the Convex virtual machine, based on, really old school computer science engineering and mathematical concepts, so that it's very, very clean, very elegant, and very efficient. So this technique is basically called the lambda calculus. And this is a perfect way of letting people express the logic that you want to execute in smart contracts in a very sort of robust and predictable way. So we've got this great programming model, and as well as that, we also have, because of the power of the Convex virtual machine, we're able to make it an interactive programming environment. So people can actually compile, edit, update, experiment, all of this online, on the chain, on the decentralized network. Which is a very powerful capability, which makes developers much, much more productive. You can instantly see the results of the code that you're developing, and that's a very powerful tool when put in the right hands.
So, all of which amazing. I can't believe you've managed to get them all in one solution. So that's pretty incredible. And just as a last point, what advice would you give to anyone who wants to get involved in crypto, blockchain, and what advice would you give people to sort of see the wood through the trees?
Well, I think always the best way to work it out is through conversations. So, I strongly encourage everyone to come and join the Convex community. We run basically an open source, open community. Anyone can join, anyone can ask questions, and always happy to discuss and create new ideas. And lots of people have had some fantastic ideas about sort of the next generation of applications that we can build with Convex. So if that's something that interests you in the crypto space, then, please do join our Discord community or join our GitHub open source community, and happy to talk with you all there.
Awesome. Thank you for your time, Mike. It's been an absolute pleasure. Hopefully we can get you when you're not so busy with preparations for mainnet launch, and we wish you good luck with that.
Thank you very much.
Thank you, Mike.